Good day. You should have a booklet that says the brain sarcophagus for reasons you may figure out sometime. And this is not only providing notes, it really becomes your summary booklet for this section. And this is a tiny section, so hopefully there aren't too many problems with it. Because it's such a big booklet, I'm going to do it in a series of probably 4 videos. And we'll just go through page by page. So some of this stuff we've covered already. In chapter 10, the last 5 or so pages of the textbook, we looked at electrons in atoms, and that meant you were figuring out electron configurations for assorted atoms. So we know electron arrangement is hugely important because it's going to dictate the chemical reactivity for a given element. We want to arrange these properly. In previous years, we'd arranged them in what we called shells, but now we put them into orbitals, and these have a little more detail. And so this is where we're talking about the 1s and the 3p and the 4d and all that kind of stuff. And we know that within a subshell, we can put 2 electrons in each orbital. It gets us to the world of quantum numbers, where we're trying to give an address to each electron. We're trying to keep track of it. Now, not so easy because these electrons zip around, but it's a way that helps us conceptualize what is going on. So for example, if I asked you about aluminum and asked for its configuration, you would break out that periodic table of orbitals and you'd go 1s2, 2s2, 2p6, 3s2, 3p1. And you recognize there's a 1s, a 2s, a 2p, 3s, and 3p orbital. And the superscripts 2 and 2 and 6 and 2 and 1 makes 13. That we found a home for 13 electrons. You would recognize aluminum, when we look at its outer s and p electrons, has 3 electrons, and so it's in group 3. Being a metal, it would like to be like the nearest noble gas, which in this case is neon. So it means if it loses those 3 outer electrons, the aluminum ion Al3+ would be 1s2, 2s2, 2p6. So not too difficult. So we have the S, P, Ds, and Fs, and then we put numbers in front that talk about the energy levels. And so smaller numbers means the electron's closer to the nucleus, and bigger numbers means higher energy orbital, farther from the nucleus. And so here are 5 elements. We've told you number of electrons, and here are the configurations. And you can double check, but hopefully they're done right. And they should have filled in these orders. So it does get a little strange, where we go from a 3p6 to back or up to a 4s2, back to a 3d10, then hop to a 4p6. So there's a bit of jumping around. But if you're using your periodic table of orbitals, there's no sweat. Just follow the patterns like the examples we've done. So that's it on electron configurations, although I have mentioned for an ion. So if you looked at oxygen is 8 electrons, oxide ion would be 10 electrons, so we'd make this a 2p6. And again, it would be isoelectronic with neon. If we have iodine, we'd want to bump it up to 54, and so it would be a 5p6, and that would be isoelectronic with the nearest noble gas. So watch out for ions. Those are something we'll ask you about. We will move to part 2 of the brain sarcophagus video.